Good? And you'll see it should be,
It's recording.
yeah, showing it's recording there. Okay, 6.2, properties of exponents. So, we have talked about square roots. And with, oh, can you unfreeze for me? Zoe?
Yeah.
Remote, towards the top somewhere. Perfect. We have talked about square roots. And when we have a square root, like that chart showed, like square root of 100, we're bringing 100 down, it's making it smaller. Now, when we have exponents, are numbers getting smaller or larger? Well, I guess that's a pretty bad question. If we have a whole number exponent, like 1, 2, 3, 4, 5, 6, are numbers getting larger or are they shrinking? Yeah, they're getting larger. When we think exponents, we should think that numbers we're working with big numbers there. So that's what we're looking at today. We already took our warm-up. Our learning target for today, students will be able to solve problems using the 5 properties of exponents. So we are looking at 5 different properties, 5 different rules that we have when we simplify things with exponents. And you're going to want to write each one of these down. They're not complicated, but you'll need to reference them. So the first 2. Product of powers and the quotient of powers. So you'll want to write down both those names and then all those letters underneath each of those names. So if we look at the product of powers, it says that we have a to the n times a to the n. So notice our bases, our whole numbers on the bottom need to be the same. Then it'll equal, it's the same as a plus a to the n plus n. So all that means, say we have 2 to the third times 2 to the 5th. That is the same as 2 to the 8th. So we can just add those exponents together. That's all that's saying. Now, quotient of powers is the same idea. If we had something like 2 to the 5th over 2, let's say 2 to the 3rd, that would be the same as, if we write it out long ways, all we're saying is that there's 2 times 2 times 2 times 2 times 2, it's 5, isn't that 1, 2, 3, yep. 2 times 2 times 2. So all we're doing with this quotient rule is we're just canceling out 3 of those 2's. So we would get this 2 squared, because there are only 2 of those 2's left. Now you don't have to write out all those 2's when we're doing these problems, but that's the idea behind it, is there's 5 2's on top, 3 2's on bottom. For simplifying, it's just 2 2's left. Good, those are our first 2 rules, not too bad. Our next rule, power of power. So if we have an exponent like a to the n, and then it's raised to a whole nother power, then we multiply those 2 things together. So say we have something like 3 squared, the 4th power, then we would just multiply. We would have 3 to the 2 times 4 to the 8th. Now we need to be careful because if they throw negative exponents in there, say it was something like 3 to the negative 2 raised to the 4th power, then our rules of multiplication still hold. We would have 3 to the negative 2 times 4, which would be negative 8. So we need to be paying attention. If it's negative or positive, that does matter. If it were 2 negatives, then we would end up with a positive, just like if we were multiplying like a regular multiplication problem. Is that our third or fourth rule? Our third? Who's got no third? So that's power over power. You won't really have to know the names of each of these too well, but you just need to know what these rules are. That's the important thing. All right, last two. Product of a power and the power of a quotient. These are sweet names, aren't they? Easy to keep straight. Yeah. And with the power of a quotient, when it says where b is not equal to 0, that's just saying we can't have 0 on the bottom. Not a huge deal. That would be pretty tricky if I tried to throw one in with 0. That wouldn't be cool. So power of a product, we have two numbers. Let's say inside of parentheses we have, and they'll do this a lot of times, you'll see like 3 and then they'll put x. So we'll use letters. And then they'll say maybe all this is to the 11th power. Well, according to our rule, we take that 11, hand it off to the 3, hand it off to the x, and we get 3 to the 11th times x to the 11th. Or they might have like x and y on the inside of the parentheses, or x and z, like they could put anything in there. And then the last one, power of a quotient. We have a fraction, and it's all raised to a power. And like it says, that is the same as 3 squared over 4 squared. So we're just giving that squared, that 2 to the 3, moving into the 4. Hey, we don't get one for class. How do you know that? I'm having some vibes already that this table is going to be an issue, so that becomes a thing that we will just move back. And I really don't want to have to do that because you guys are young adults, so there's no reason that they babysit you. It's kind of ridiculous. All right, so those are the 5 rules. If we have them written down, we can look at problems and we can look back at our 5 rules. We can see, okay, how do these work? So just a quick example, and I guess I put one in the middle of the page. That was not the best idea. We have 6 to the negative 2, and it's raised to the power of the negative 5. Then what are we doing with that negative 2 and negative 5? Adding, subtracting, multiplying, dividing. What are we doing with that? Negative 2 and negative 5, according to our rules. Multiply. So negative 2 times negative 5 would just give me a positive 10. And that's all they're looking for in that answer. 6 to the positive 10. And the second one. Negative 5 to the, what are we doing with that 8 and 4? What do we think? A little louder. Subtracting. Yep. That was, which number rule was that? Our second rule. So they would just be looking for negative 5 to the 4th. Now I guess we'll go to this middle one. This is supposed to be on the bottom, but that's okay. If we have 2 to the negative 8 times 2 to the 3rd, I know it's kind of hard to see. But what would happen with those? What are we supposed to do? We know 2 is our base. What is our exponent? We're adding these. So -8 plus 3, -5. Now, one thing to watch out for. We do not like negative exponents. So sometimes they'll say, hey, solve this, simplify this, but make sure there are no negative exponents. So how we would write this then, super simple, we would just write it as 1 over 2 to the positive 5th. So we can get rid of that negative sign by just taking our number, putting it over 1, or under 1. Put it under 1. So we don't like negative exponents. Skip that last one. So here are 1, 2, 3, 4, 5, 6 problems that you guys will do. Once you have those 6 problems done, come up and see me or grab my attention. I will check them and you can get the worksheet for today. That's all the new learning we have. Not too bad, I don't think. Hopefully. Yeah. Maybe. Decent. So we can stop recording.